Okay, so this has the answers to the review. Now again, it doesn't have the work, it just has the answers. This file is posted in the assignment on Canvas. So you can check your answers. I'm gonna go through it. Now, remember, when it asks you to leave your answers exact, so for example, on 1, 2, and 3, this is just Pythagorean theorem. So if it said leave your answer exact, then the answer would have been 2 square root 34 for number 1, 12 for number 2, and 12 square root 30 for number 3. If it said to round it, then it would have been that decimal. So you need to read how it wants the answers left. Now, you're also going to need to be able to classify or tell if the 3 numbers that you end up getting are a Pythagorean triple. Remember, in order for 3 numbers to become a Pythagorean triple, they have to be integers. You cannot have radicals as one of the side lengths or a decimal. So as long as all 3 sides are integers, then they do form a Pythagorean triple. So be able to answer questions like 1, 2, and 3, where it's going to ask you to find a missing side length. And all you're doing is a squared plus b squared equals c squared. Then numbers 4, 5, and 6. You had a question like this on the quiz. They'll have one like this on the test, where it's going to ask you to classify. Is the triangle acute, obtuse, or right? It's also going to ask you, will it form a triangle? And that's where you take the 2 smaller sides, add and subtract them, and then make sure that that biggest side fits in between. So the biggest question that has come up today is everybody's asked me to do number 5. So in order to first check to see if these side lengths on number 5 form a triangle, what we would have to do is figure out which 2 sides are the smallest. So I'm going to multiply 2 times the square root of 2, and this is actually approximately equal to 2.8. Then if I do 6 times the square root of 3, this one's about 10.4. These are approximate. So I can see my 2 smaller sides are these 2. So if I add them and subtract them, I'm going to see that the 10.4 fits in between that sum and difference. So 10.4 does fit in between. So yes, these will form a triangle. Now, when you're testing to see if it is acute, right, or obtuse, do not use the approximated values. We're going to go back and use the radicals. I'm going to take the 10. Actually, let me do the c squared first. So I'm going to do c squared, question mark, a squared plus b squared. So remember, if c is bigger, c squared, it's obtuse. If c squared is smaller, it's acute. And if it equals a squared plus b squared, it's right. So I'm going to do 6 square root 3, square it, 10, square it, and then 2 square root 2, and square it. So this, actually, the 2, I square the 6 and the radical. So this becomes 36 times 3, which gives me 108. 10 squared, 100. This one I'll square the 2, square the radical. 4 times 2, and I get 8. So I get 108 equals 108. This is a right triangle. However, it is not a triple because 2 of the side lengths are radicals. So not a triple, but it is a right triangle. So that was 9-1. In 9-2, this is where we covered special right triangles. So you need to memorize the relationship of the sides. Soon as you see you have 2 congruent sides, this tells me it's the 45, 45, 90. So this would have been A, this would have been A, and this hypotenuse is a square root 2. So you just take what A is and put root 2 behind it. When it's the 30, 60, 90, across from 30, we memorize to be A. Across from the 60 is A square root 3. And then across from the 90 is the 2A. So in order to find A, I need to solve this equation. So I'm going to divide it by 2, and A equals 7. So X equals 7, and if they had asked you for this side as well, it would be just 7 square root 3. So be able to recreate your special right triangles and find missing side lengths, leaving it in radical form. So that was 9-2. 9-3, this is where we learned about geometric mean. And again, you have these answers. It's in the assignment. But again, I'm going to post this video. So for this one, we learned 2 proportions. We learned the first one, which was segment 1 over altitude, altitude over segment 2. The other proportion we learned was hypotenuse of the original right triangle over leg, and then leg over its segment of the hypotenuse adjacent to the leg, which is what I call SOHAL. So be able to memorize these proportions and apply them to find a missing piece of the triangle. Then in 9, so let's go ahead and let's say we do number 13. So number 13 here, notice this is my original right triangle here. So this is the original right triangle. Here's the right angle. So this is a leg. The X is the hypotenuse. And the 16, this is going to be the SOHAL, the segment of the hypotenuse that's adjacent to the leg. So when I go to fill this in, I'm doing this proportion. I'm going to be doing hypotenuse over leg, which is 20. Same leg, 20 over its SOHAL. So 16 times X, 20 times 20 is 400, divide by 16, and 400 divided by 16 is 25. So for number 10, this one is the other proportion. So this is segment 1. This could be segment 2. The altitude is the 9. So I'm going to be doing segment 1 over altitude, altitude over segment 2. I'm going to cross multiply. 6 times X, 9 times 9, 81 divided by 6, and I get 13.5. Let's say I wanted to label the parts here. So here is my original triangle. So that would tell me this is a leg, and then this is my hypotenuse. Notice the X, this is the altitude. And then the segments are the 2 pieces of the original hypotenuse. So this could be segment 1, this could be segment 2. Really, where you put the 1 and the 2 doesn't matter. So as soon as I see that what I've got numbers on are going to be the segments, and I'm looking for the altitude, soon as I see that that's what I have, then that's going to be a clue that I use this one. Because I have this, and then this is what I'm looking for. 4, this is where we learn the tangent ratio. So the TOA. This is tangent of the angle is equal to opposite, that's the O in the acronym, over adjacent. So be able to use this tangent ratio to find a missing side length or a missing angle measure. Then in 9-5, this is where we learned sine and cosine. So remember sine, that's the slope. So that would be opposite over hypotenuse. And then we learned cosine, which is going to be adjacent over hypotenuse. And again, be able to use these to find a missing side length or a missing angle measure. Now, one thing I want to zoom in here to show you, and we've done a bunch of the examples like 24 through 29 when I just went through those warm-ups. But one thing I did not cover in the warm-ups, and it was in the homework, was questions 30 and 31. So whenever you're asked to write the sign of a number in terms of cosine, remember the angles are complements. So to rewrite sine of 72 with the word cosine instead, all you have to do is take 90, subtract 72, you get 18. So now to rewrite this, but now use the word cosine, you take the complement and put the word cosine now instead. Be able to do this tomorrow. This is like a gift, okay? Or number 31, if they give it to you in cosine, you take 90, subtract the angle that was given. So 90 minus 29. And then you're going to rewrite it now with sine, but put 61. Because these are complements, and the complement, the sine of one angle is going to be the same as the cosine of its complement. So be able to do this tomorrow. Then 9-6 is where we solve the right triangles, which was really applying everything into one thing, where you had to use sine, cosine, and tangent to find missing sides or angles, or if you were given two sides, just do Pythagorean theorem. One other thing that we didn't do in the warm-up, let me show you 32, 33, 34. Whenever they ask you to use your calculator and they give you the answer, all you're doing is taking your calculator, and when you want to find the angle measure, remember it's inverse. So for number 32, you would hit second, cosine. It's going to open up cosine -1. Then you take this decimal, put it in your calculator, close the parentheses, hit enter, and then we're going to round it to the tenths place, so 71.3 degrees. If it were number 33, you would hit second, sine, it opens up sine -1, put the decimal, close the parenthesis, hit enter, and you get 65.5. So be able to do questions like these where it's, again, a gift. And again, also be able to solve a right triangle. Again, it'll be important that you show me what you're putting in your calculator. Because if your finger slips, let's say it was this question, and instead of hitting 32, let's say you hit 0.33, you're going to get the wrong answer because your finger missed the button. So show me what you think you're putting in your calculator.